Hi guys, here I am at University Lake. As you can see, we're having a gorgeous day here today. I'm very excited to kind of take you on a virtual field trip and also talk about weather, which is our topic for the week. So let's go ahead and make some observations. What can you guys tell just through this video about what the weather might be like here in Montevallo? And we're in June, early June. So I think it's technically still spring, but we are very close to where the seasons change over into summer. Let's also just look at the sky. So meteorology, as you guys know now, is the study of the atmosphere. The atmosphere is the sky. It's where everything happens when we're talking about weather. So I'm very excited to kind of dissect and look into that a little bit further and talk to you guys about the anatomy of the sky. So I found a shady spot where we are sitting on the trail that surrounds the lake. You can kind of see it through the trees in the background. I'm not sure if you guys can hear it, but you might be able to see evidence of a phenomenon that's going on right now. Oh, maybe like how those tree branches are moving by themselves. Is it really by themselves? Or is it the wind? Is wind part of weather? Let me know what you guys think. And then when we explore, maybe we'll answer. So, as I said earlier, meteorology is the study of the atmosphere. So this is a big word, and whenever I see big words, I like to break them down. Sphere is a shape, right? It's kind of like the same shape as a ball, or you could say like our planet Earth, right? Atmos means air. So the technical definition of atmosphere is the layer of gases that surrounds Earth. So I'm going to draw a sphere that's circling Earth on all sides, right? And this dotted line represents our atmosphere. So meteorology studies atmosphere, and it also is used to help predict the weather. As we know, you can make weather forecasts when you study meteorology. So I feel like we should really dissect this a little further and get a little more details about the atmosphere. So here's our atmosphere. There's actually layers in our atmosphere, okay? Can anyone guess how many? I'm going to take a little chunk and cut it up. There's 1, 2, 3, 4, 5 layers. And we're going to talk about those 5 layers in depth. Ta-da! So I've written all the names here of our 5 layers. So let's pretend like I just zoomed in on my other drawing. We're going to start at the bottom, okay? This is Earth down here. So this first layer is known as the Troposphere. The Troposphere is anywhere from 4 to 12 miles thick. So around the equator on Earth, it's only 4 miles. Around the poles, it's 12 miles wide. So that being said, around here in Alabama, it's going to be closer to 4 miles thick, okay? What is cool about the troposphere? Well, it's the part where we live, part of the atmosphere where humans are, where all of our weather takes place. So this is the most dense chunk of gases because it's closest to the Earth, okay? So let's say, so Mount Everest, the tallest point on Earth, right? Mount Everest is about 5.5 miles tall, okay? And weather, now when we're talking about weather, we're talking about like water vapor and dust particles. That's all happening here in the troposphere. So the dust particles that are in our atmosphere give things that the water vapor can seed and form clouds around. Okay, so clouds, which is part of the water cycle, the rainfall, all of that is happening in the troposphere. And depending on what type of cloud we're talking about will depend on what part it's in. So we can even have a cloud on our Earth's surface known as fog, right? So clouds can really happen anywhere in here, but typically they only happen in the troposphere. So that's because when we get up to the stratosphere, there's basically no more water vapor left and the air is very dry and very thin. That's why planes fly up here in the stratosphere. So planes fly at 30,000 feet, which is about 5.6 miles. So they actually fly above the clouds. That way there's really no interference for them. They can go faster and they don't have to fight against the weather unless they go to land, right? Also in the stratosphere, we have the ozone layer. So I'm sure you've heard about the ozone layer before. It absorbs a lot of the radiation and energy from the sun and is responsible for the greenhouse effect where these gases below are hotter, okay? So when we're thinking about temperatures, the closer you are to Earth, the hotter it is. In the troposphere, it's weather like this, right? It can be hot or cold, but either way, it's warmer, and as you go up, it's going to get colder. Okay? When you're in the stratosphere, it can be anywhere. So now that we're in the stratosphere zone, the stratosphere starts at negative 60 degrees Fahrenheit. That's really cold, right? Negative 60 degrees Fahrenheit. But when you get to the top portion of the stratosphere, it's actually negative 5 degrees Fahrenheit, which means it got warmer. Even though the troposphere is constantly getting colder up to negative 60, now it's warmer. Well, that's because of that ozone layer we were talking about. It's adding a little bit more heat back into the stratosphere layer. So, in the stratosphere, the top of it is about 31 miles high. Okay, now we're going to go past 31 miles into the Mesosphere. The Mesosphere goes from 31 miles to about 58 miles high. So now we're in the Mesosphere. Well, what's cool about the Mesosphere? I will tell you that the Mesosphere is actually the coldest layer on Earth. Right? Any guesses on how cold it might be all the way up there? I will tell you. Negative 130 degrees Fahrenheit. Freezing. That's more than freezing. That is very, very cold, right? So in the Mesosphere, we don't really have planes flying up there. There's not enough oxygen for the plane engines to run in that level. The air's even more thinner, right? So this is, like I said, the most dense portion of air. This has a little bit. Now we're really getting very, very thin. Not as many particles, if any at all, right? What does happen in the Mesosphere, which is very cool, meteors burn up. So whenever you see a meteor shower at nighttime, if you are so lucky to see one, you'll see them start to kind of burn bright colors, and that's when they enter the atmosphere. This is the part of the atmosphere at which they burn up in the Mesosphere. And that's the coldest part. All right, now we are traveling into the Thermosphere. The Thermosphere is almost considered outer space. It's already that thin. Things are getting close to what we would consider space. So this Thermosphere is going to actually get very, very hot. Any guesses how hot? $27,000 degrees Fahrenheit. So we went from the coldest to the hottest pretty quickly. And this is because there's really nothing to protect it. This is getting a lot of the sun's radiation. There's nothing here blocking it from being absorbed in this level, right? This is also the widest layer. So we go from 58 miles all the way to about 400 miles thick. So we are 400 miles at the top of the Thermosphere from the surface of Earth. That's crazy. What cool things can happen in the Thermosphere? Have you guys heard of the Aurora Borealis? So also known as the Northern Lights. There's also some that happen in the Southern Hemisphere, but the aurora is when these charged particles from space collide with atoms that are here in our Thermosphere, and as the result of this collision, it emits photons or light energy. So it leaves a very cool phenomenon. If you haven't checked it out before, look up Aurora Borealis. It's very pretty. This is happening in our Thermosphere though, right? Also towards the top of our Thermosphere, we have the International Space Station and shuttles that orbit the Earth. That's happening at the Thermosphere almost into the next layer, which is the Exosphere. So the exosphere doesn't really have a strong boundary line. Like these, we could say, okay, this goes up to this many miles, this is this many miles thick. The exosphere starts at the end of the thermosphere, and it kind of slowly fades off into outer space. Slowly, we're losing less and less particles until it's just the emptiness of space, right? And all the way up here, the temperatures can vary depending on whether it's nighttime or daytime. And this is where we have satellites. So when we shoot up satellites to orbit the Earth, they help us take pictures of the Earth from very far away, or look at different things like clouds and weather patterns. Our satellites are all the way at the edge of the thermosphere, almost fully into the exosphere, right? So, what did you guys learn today? What was one thing new that you guys learned? I thought it was very cool to know that planes are in the stratosphere. So I've seen pictures, and maybe you guys have been on a plane before, when you're looking out of the window, out of the plane, and you can see the clouds are below you. Well, that's on purpose, right? They're flying at a level of the atmosphere that is higher than where the clouds are forming and where our weather typically takes place. I thought that was very cool. I hope you guys enjoyed this virtual field trip to the lake. Hopefully as I hike out, maybe we can see some cool things. I hope you guys enjoyed this field trip and learned more about the anatomy of the sky and why meteorology is the study of the atmosphere, all parts, right? They have to know a lot of information about wind, the water cycle, and in general, the atmosphere. I can't wait to see you guys next time when we will be talking about the night. Hi guys, so I just want to say thanks again for joining me. A few reminders: if you do get to come out to University Lake, wear closed-toed shoes. I also suggest wearing pants if you can, to help protect yourself against poison ivy or maybe ticks. It is that time of year, so if you have bug spray or sunscreen, that would be a great idea as well. Did you guys see all of those cool birds at the end of the hike? I thought that was amazing. I hope you guys enjoyed this virtual field trip, and I cannot wait to see you guys next time.